Okay, here's our first video for the sheet that you need to do on Tuesday 4/7, worksheet 8.2, number 1, examples. So my first problem, you will notice, has a common denominator. So very much like a lot of what you've already done, you're just going to combine your numerators and notice that 8y minus 3y is 5y, and negative 8 plus 7 is negative 1. Now that you have the numerator combined, you compare the numerator and denominator. You see they're identical, so you can simplify, and it's going to be 1. The second example is just as easy. Again, we have a common denominator, nothing to do, so we combine our numerators. 5a and a is 6a, 2b and negative 3b is negative b. But nothing reduces. Even if I factor the denominator into a plus 2b and a minus 2b, nothing happens, and so we're simply done. Now, in example 3, I need to teach you an important point. We do have a common denominator, but it's not a plus sign, it's a minus sign. And this really muddies the waters when we have that. So just like we've done previously when our denominator was a negative number, what did we do? We negated the top and the bottom, the numerator and denominator, so we can get a plus sign. Now this will be a pattern we're going to do every single time. We will never let this be minus a numerator. It must always be plus a numerator. And so you will find that we will be, instead of saying minus a positive, we'll be adding the negative. So now we have similar terms in the denominator, so we can combine our numerators, and notice the only thing that combines are the two terms 4xy and negative 6xy, and that gives us a negative 2xy. Now once again, just like all those sheets that were in the packet that were entitled Spring Break, when we actually did it the week before Spring Break, you need to factor. And so the only factors of 3 are 3 and 1. And the ones that add and give you negative 2 would be a negative 3 and a positive 1. Note that these are alike, so I can reduce, cancel, simplify, and I'm left with x plus y. Now, for example 4, which will be similar to problem 4. Again, notice this nefarious minus sign between the terms. So what do we need to do? We must negate the numerator. So make this a plus, negate the numerator. And now we look at the problem, and what's wrong? We do not have a common denominator. So I factor, and I have a 10x plus 1. I factor, and I have a 14x plus 1. And this is 2 times 5, and this is 2 times 7. So the common denominator would be 2 times 5 times 7, or 70 times x plus 1. Now, we've played what's missing before, and you had to do that in some of your other work when we just had plain simple numbers. So now we're going to do what's missing, and we're going to have variables. So when I look at the 10, he's missing the 7. I look at the 14, and he's missing the 5. So when I go to look at my 4x minus 5, it needs a 7. What does the negative 2x plus 7 need? It needs the 5. So I go ahead and I put the missing terms in. I distribute, and that gives me 28 minus 35 and negative 10x plus 35. I combine, notice the 35's cancel, and I have 18x. But careful, don't quit. Check to see if there's a common factor. Yes, our mortal enemy, the common factor, the factor we all forget to do. And what do these turkeys share? They share a 2. And if I don't reduce each of those by 2, I will not have a correct final answer. All right, to the next trouble that we ensue in these problems, which we already did on a spring break worksheet. We don't like to see 3 minus x. We always want to rewrite with the variable first. So I have negative x plus 3. Then again, we don't like a negative sign on our variable because when we factor, we've always had a positive sign. So what do I need to do? Notice there's the plus sign here already. So how do I undo that? Well, just remember when you saw negative 2 over negative 3, what did you do? Didn't you just negate the denominator and negate the numerator? And so what are we going to do here? Negate the bottom. X minus 3, negate the top, negative 2, and note it will have the same value as the original. And so now we have to find our common denominator. We always factor the quadratics automatically. And we see it is indeed the given denominator for the first one. And so when we say what's missing, the first one is missing nothing, but the second one is missing x plus 3. So I rewrite this problem for x, and I put in the missing term for the next one over the entire denominator. I distribute and get 4x minus 2x minus 6. I then combine and get 2x minus 6. No, we're not done. You must factor. Does it reduce? Yes, it does, and so you must reduce. Now, it doesn't always have to reduce, but in most of my problems, they will reduce because I'm trying to get you to think about the reducing. Now, I'm covering this up as we travel into another room where I have 5 more boards for us to discuss to finish our problems. Not enough space anywhere in my house. And we're now in my dining room. See the china cabinet in the background. Okay, what happens when we see problem like number 6? It's going to have the minus. So I'm going to rewrite this as plus the opposite. So I have a negative 3. Note I went ahead and factored my denominators. Notice they both share x plus 2, but x minus 2 is missing in the second, x minus 1 is missing in the first. But our common denominator is just x plus 2, x minus 2, and x minus 1. And as stated already, the first denominator does not have the x minus 1, and the second denominator does not have the x minus 2. So 4 needs r minus 1, and negative 3 needs r minus 2. So I place them in their appropriate positions. I distribute 4r minus 4, negative 3r plus 6. I combine, and I have r plus 2. And notice, if I can keep the camera steady while I'm doing this, both of these are x plus 2, but when I cancel, you can't leave nothing in your numerator. It has to be a 1. We are allowed to not rewrite anything with the denominator because that 1 is understood. So my final answer is 1 over r minus 2, r minus 1. An example for problem 7. Notice I go ahead and factor the first one. The 8 minus y I rewrite as negative y plus 8. Then again, I want this variable positive, so what do I have to do? Negate the bottom and negate the top. I was trying to write on the board. It's not doing any good. It wasn't as sturdy as when it was sitting on the piano. Anyway, if this had been negative 2 over negative 3, this is now positive 2 over positive 3. Notice the common denominator is the first one. So what is the first denominator missing? Nothing. What's the second denominator missing? Y plus 8. So the negative 4. The top and the bottom need y plus 8, but we automatically have the y plus 8 on the bottom, but the numerator has to have the y plus 8. I distributed and got negative 4y minus 32. When I combined, I was left with negative 4y. There is not a common factor top or bottom. There's not a binomial factor top or bottom. And so this does not simplify any further, and we're done. Example 8. In example 8, it looks pretty simple. It's actually easier than some of the other ones. We just have to factor. The common denominator is the first one. The second denominator, what's he missing? Y minus 8. So what does the numerator have to have? Y minus 8. I put it in. I distribute like we did in the other ones. 4y minus 32. I go ahead and combine 4y plus 32. But now I must factor. Do not forget to factor. I have 4 times y plus 8. And notice again, this will reduce. And so now I'm left with 4 over y minus 8. And we're done. Problems 9 and 10 get particularly messy. These are teacher-made problems, as are all of these, but when you get to 10, it's definitely teacher-made. This has a different issue. Notice there's a minus sign, so I could have changed the top, but here's something that's really cool. Look at this. When you see negative times the fraction 2 divided by negative 3, do you change the top and put a plus in front? No. You just take these two signs and negate each other, and so they're now both positive. This is the concept here. I rewrite it in the negative x plus 8 as usual, but rather than negating these two, I can just say, oh, this negative times this negative, negate, pause, and now then if I do negate here, I'm now positive and I've negated, and I've left my numerator as is. I think that's pretty cool to go back and use what you already know. We've been busily doing this particular fraction. We'd been busy doing this one so far where you needed to negate the bottom and then negate the top. So the bottom was positive. So let's face it, folks, this is pretty cool that we don't have to do all that extra work. And so now I have the fractions the way I want. My common denominator is the first one. So when we play what's missing, the first one isn't missing anything, but the second one's missing x plus 3. Now when I distribute, I've got a binomial. So you have to do first, outers, inners, last. But since this is an easy one, we know it's x squared. We can just add those two and get positive x, then multiply those two and get negative 6. We were used to doing that for factoring. Now we combine the terms. We have x squared plus x minus 30. Yep, we got a factor again, folks. So I get x plus 6 and x minus 5. And notice what happens again. We have two binomials that will reduce, and I have x plus 6 over x plus 3 for my final answer. Last problem, definitely teacher made. Notice the middle one is doing what the last one did. I first rewrote it, and now I'm going to go negate, and I get 3 over x minus 5. The first one has the common denominator. This one is missing the x plus 3. This one's missing the x minus 5. And so we go ahead and we put those missing factors in. We distribute and get that mess. 3x plus 9 and 4x minus 20. What am I going to do? I'm going to go ahead and combine. What else do I have to do? I have to factor. And when I factor, I get x minus 5 and x minus 4. And now I must simplify because, again, these factors cancel. And so I'm left with x plus 4 over x plus 3. So ends the video.